Simple distillation is an important separating technique. It's used to purify water and produce alcoholic drinks such as whiskey. Distillation separates mixtures based on the substance's different boiling points. It is the combination of two physical changes: evaporation followed by condensation. During evaporation, a liquid is heated until it changes state to a gas. Condensation occurs when a gas is cooled down until the substance reaches the liquid state. In this video, we're going to use simple distillation to obtain a sample of pure water from a mixture of coloured dye. The mixture is a solution. Water is the solvent and the coloured dye is the solute. The solution is heated until it boils and the water molecules evaporate. The water vapour then condenses and pure water is collected in a test tube. Find the full methods, safety information, and the activities in the supporting resources. Before we start, put on your safety glasses. Place a heat-resistant mat on the base of the clamp stand and place a Bunsen burner on top. Next, place a tripod and gauze above the Bunsen burner. Then, stand a conical flask on the gauze and carefully clamp the neck of the conical flask to keep it stable. Now, we're going to use the second clamp. We're going to put a beaker of ice water underneath. We're then going to take a test tube and put it in this clamp and very gently fasten it. Be careful not to over-tighten the clamp because the glass might crack. Next, measure 20 centimeters cubed of solution in a measuring cylinder. Then pour the solution into the conical flask. Next, add some anti-bumping granules. Okay, next we're going to take the bung with delivery tube. We're going to place the bung into the conical flask like so, whilst at the same time getting the other end of the delivery tube into the test tube. Make sure the end of the delivery tube stays above the water in the collecting test tube. Okay, right now we're going to light a Bunsen burner. We're going to start by taking a match and transferring the flame to a splint. Twist a hole on your Bunsen for a blue flame, and to reduce the size of your flame, gently twist your gas down. Or, to boil the solution gently, you can hold the Bunsen by the base and move slowly in and out like this. Observe the water vapour as it rises through the flask and up to the delivery tube. See it cool and condense back to the liquid state in the beaker of ice. We call the liquid we collect the distillate. This animation shows the water and coloured dye particles in solution. The water particles are blue and rise up through the delivery tube as the water evaporates. The coloured dye stays in the conical flask because its boiling point is higher than water's. Collect about 1 centimeter depth of water and remove the test tube, then turn the Bunsen burner off. Simple distillation can be carried out on a larger scale using Quickfit apparatus. In this setup, we use a thermometer or temperature probe to measure the temperature of the vapour and water-cooled Liebig condenser to aid the cooling process, so that the water vapour condenses back to a liquid. The Liebig condenser consists of an inner tube and an outer sleeve. Cold water flows through the outer sleeve, entering the bottom of the sleeve and leaving at the top. Hot vapours enter the top of the inner tube and condense as they pass through. Finally, the liquid distillate comes out the other end of the tube and is collected in a test tube. Now let's test our product and prove that we actually collected water. I'm going to take a few crystals of anhydrous copper sulfate and place them on this watch glass, like this. Now I'm going to take my sample from earlier. I'm going to use the pipette, take out some water, and then I'm going to put it in here. The white powder has turned blue, confirming water is present. Now, what further physical test could you carry out to confirm the collected water is pure? Simple distillation is a separating technique. We've seen how you can use it to collect a sample of water from a coloured solution. Think about how you could separate water from an aqueous solution of a soluble salt, such as copper sulfate. What other mixtures could you separate? Remember to download the supporting resources from the RSC Education website. Thank you for watching and have fun with your experiments.